going to go through the mid-chapter review found on page 190 in your textbook. This covers section 3.1, 3.2, 3.3, and 3.4 and 3.5 from your textbook, and just kind of give you a feel for some of the questions you may find in your homework and on the exam as you get ready for those things in chapter 3. The first section talks about divisibility of a number. So if we have a number like 420, and I ask you, is 420 divisible by by 6. And the test for divisibility by 6 is to first figure out, is it divisible by 2, is it divisible by 3? And if it is divisible by both of those numbers, then it is going to be divisible by 6. The test for divisibility by 2 is to say, is it an even number? And yes, it is an even number. We look at the last digit, and the last digit either needs to be a 0, 2, 4, 6, or 8. And in this case, it is a 0, so it is divisible by 2. And then we're going to ask ourselves, is it divisible by 3? In order for a number to be divisible by 3, it needs to be that when you add up all the digits in the number, that number needs to be divisible by 3. So in this case, I'm going to take the 4 and add it to the 2 and add it to the 0. So 4 plus 2 plus 0 gives me 6. Is the number 6 divisible by 3? Yes, it is. So since we answered yes to both divisible by 2 and divisible by 3, we can say, yes, this number is divisible by 6 as well. Now we could also say, is this number divisible by 5? And in order to know if it's divisible by 5, we will want to know, does it end with a 5 or does it end with a 0? Those are the only two types of numbers that are going to be divisible by 5. In this case, our last digit is a 0, so yes, it is also divisible by 5. Is it divisible by 10? The only way it can be divisible by 10 is if that last digit is a 0, which we've talked about, yes, it is. So it is divisible by 2 and 3 and 6 and 5 and 10 in this case. So there are several little tests to see if a number is divisible by these smaller numbers that you need to be familiar with. Another topic in this first half of the chapter 3 is factoring. So we want to find the factors of 24. And in this, for finding the factors, we want to find all of the numbers that multiply together to give us the number 24. So what are the ways we can find that we can multiply two numbers together to get 24? Well, obviously we can take 1 times 24. That will give us 24. We can take 2 times 12. That gives us 24. And we can take 3 times 8. That will give us 24. And one last one is 4 times 6 gives us 24. And we can think through the other numbers. 5, is there something we can multiply by 5 to get 24? No. And 6, we already took care of here. 7, there isn't anything we can multiply. So once you start to go through the numbers and you get a repeat, then you know you have found all the factors. So the factors of 24 are simply the numbers that we are using here. So all of these numbers, 1, 24, 2, 12, 3, 8, 4, and 6, are all factors of 24. There is also a way of factoring things that your book goes through of prime factorization. Prime factorization gives us a way to factor a number so that the factors all are prime numbers, which means they are not divisible by anything other than 1 and themselves. So an example of a prime number would be 3. 3 is only divisible by itself and 1. Or 5 is a prime number. 7 is a prime number. 2 is a prime number. So we're looking to get our prime factorization into finding our factors that are only divisible by 1 in themselves. So if we have the number 24, and we can make a factor tree with the number 24, we can pick any two factors of 24. So I'm going to pick 3 and 8 as my factors of 24 that I'm going to start my factor tree with. 3 is a prime number, so we're done on this branch of the tree, but 8 is not a prime number. So we want to factor that further. We want to factor it into prime numbers. So 8, what do we multiply together to get 8? Well, 2 times 4 gives us 8. We're getting closer. This 3 here was a prime number. Our 2 here is a prime number, but 4 is not. 4 is divisible by 4 and 1, but it is also divisible by 2 and 2. So we can branch this out even further. And so we end up with 3 times 2 times 2 times 2 is the prime factorization of 24. So we can write that this way, or we can simply write out 3 times 2 times 2 times 2 is the prime factorization of 24. You can check for yourself to make sure that that all works. But this is the prime factorization, and this is the technique you'll want to use for figuring that out. Also in the first half of this chapter is multiplication of fractions. We have something like this, where we're taking 7 and we're multiplying it by 1/9. How do we do that? Well, we are simply going to multiply everything on the top by everything on the bottom. And remember that the number 7 is like we have 7 over 1. We can put any whole number into a fraction by writing it over the number 1. So in this case, we're going to have 7 times 1 as what I'm multiplying together on the top, and 1 times 9 is what I multiply together on the bottom. So my answer in this case then is going to be 7/9. So 7 times 1/9 gives me 7/9 as my answer. If I have 2 fractions that I'm multiplying together, like 4/15 times 2/3, I'm simply going to multiply everything on the top, multiply everything on the bottom, and write a new fraction over here. So 4 times 2 is 8. 15 times 3 is 45. And in this case, my answer is 8/45. I can also do this when I am multiplying using a negative fraction. So if I have the fraction 5/11 times negative 8 halves, and multiply everything on the top together. So 5 times negative 8 is negative 40. 11 times 2 on the bottom gives me 22. So I have negative 40/22 as my new fraction, as my answer for this multiplication problem. Now when I end up with a fraction like this, I may want to try to simplify it. We may end up with some ugly looking fractions that we want to find a simpler version of. So if we have the fraction 24/60, we're going to use the factorization that we discussed a few minutes ago and try to factor these. We're trying to find common factors that these two may have. So I'm looking for something times something else in both the 24 and the 60. So I'm going to think, 6 is a common factor to both of these. That might be a good start. Or 2 might be a good common factor to start with. I'm actually going to start with the number 12, because I know 12 is a factor in both of these. So I take 12 times 2, which is another way I can write 24, 12 times 2. And on the bottom, I know that 60 is the same thing as 12 times 5. And I can simplify this by knowing I have a 12 over 12. And 12 over 12 is another fancy way of saying the number 1. So I can pull out that part of it because it's the number 1. And I'm left with 2/5 as my simplified answer. So I went from something a little more complicated, like 24/60, and I end up with something much simpler as 2/5 as my answer. I can do this with positive numbers, negative numbers. I can do this with variables. If I have the fraction 17x over 17x, and I would want to factor this out, I want to look for the factors of this, and another way I can write this is to say 17 times x, and the bottom I can rewrite as 17 times x as well. I can look at this and say, well, 17 over 17, that's just another way of saying 1. And x over x, just like I said 17 over 17 was another name for 1, x over x is another name for 1 as well. So I'm left with simply 1 times 1, which is 1. So this fraction, 17x divided by 17x, I can simplify that to simply be the number 1. We are also going to use the idea of multiplying fractions together to calculate area. And we've already done a little bit of this with whole numbers, but we're going to do it with fractions as well. So problem number 40 on the chapter review on page 191 says the length of a rectangular ice skating rink in the atrium of a shopping mall is 7/100ths of a mile. So that's one dimension. The length of it is that, and the width of it is 3/100ths of a mile. So if it's helpful to draw a picture here, we can draw a picture of our skating rink. And we want to know what the area of that ice skating rink is. So the 7/100ths is going to be is that dimension, and the 3/100ths is this dimension. And in order to find the area, we multiply the length times the width. And we can do this whether they're fractions, decimals, whole numbers. So if we took 3/100ths times 7/100ths, we're going to simply multiply everything on the top together, and we get 21. We multiply everything on the bottom together. So we have, as our area, 21 10,000ths. And we can't forget our units here. We have square miles. It works just as well for fractions as it does for whole numbers. Number 39 is a little bit different way of using fractions, and the idea of a ratio. It says out of every 500 households that own pet birds, 60 obtain veterinary care for their birds. What is the ratio of households that own birds that seek veterinary care for their birds to all households that own birds? So we're going to make a ratio. We're going to have a fraction with some number on the top and some number on the bottom. And it asks us to find a ratio of the households that seek veterinary care for their birds to the ratio of all households that own birds. So it was 60 households actually obtain veterinary care for their birds. So we'll put the 60 on the top. And there are, out of every 500 households that own birds. So the ratio of households that seek veterinary care to the ratio to the number that own birds is 60 over 500. And we could leave it at that as a ratio, or if we wanted to simplify it, we can look to factor 60 and 500, and we could figure out some things that could cancel out, and we could get a ratio then, a much simpler ratio of 3 to 25. So I could say for every 500 households that have birds, 60 of them get care for their birds, or I could say for every 25 households that own birds, 3 of them receive veterinary care for their birds. Good luck completing your homework, and good luck on taking your Chapter 3 exam.